Welcome to Busy Working. We are sitting here with a well-known figure here in Braam van Emmenes. Braam, thank you for joining Busy Working today. We know you've got a busy schedule, so we'll start off straight with the first question we've got. So can you explain the concepts of earthing and bonding in a solar installation for us? So obviously we'll be covering earthing and bonding with lightning and surge protection in this episode.
Good morning. Thanks for the welcome. Earthing and bonding is something that is very misunderstood in our industry. There's a vast, big difference between earthing and bonding. Most people think once something is earthed, it's fine. It is not fine. It's a combination of the two. Let me try and explain earthing and bonding in layman's terms. Earthing, or let's say where it arrives from, where does it start? In any electrical installation, if you get shocked, for instance, you get electrocuted.
Okay.
What actually happens is that live or conductor, wherever you touch it or what, that power wants to return to its source. Now, if I could have drawn a picture for you, it would have made much more sense.
Made more sense.
But it wants to go back to its source. You will not get shocked by something if there is not a return path. It's like switching off a light switch. If it's off, you cannot get shocked. You will get shocked if you touch that and you touch an earth point. Because now you are closing the loop and that will form a circuit, and that the power then will go through you and then you get electrocuted. So it wants to return to its source. So earthing is crucial, important for the safety to have a minimum resistance so that your power, in a case of a short circuit or a leakage or a fault or whatever the case may be, can return safely to its source. Bonding, on the other hand, is to make sure that everything is connected together. If everything is connected together and are conductive, you actually will never get shocked. For instance, if we take this room, if this carpet and the chairs and the wall and the microphones and everything was equal potential bonded, and everything was equal in the conductive format with a low resistance, a lightning strike can hit outside. The potential will rise, but because everything is on the same potential, you will not get shocked.
Oh.
Now, if you want to go further and deeper into this, you can basically just go and Google Faraday cage, and that will give you a much more and a bigger information.
Understanding about it.
Understanding and how it will work. That's why a person in a Faraday cage will never get shocked.
Google.
Now, if you want to Google it, I think one of the best examples is in Dubai, the Burj building.
No, that Burj Khalifa
Burj
building.
Khalifa, the highest building on earth, is a Faraday cage. That whole building is built out of steel. It is Dubai's lightning rod. And take a massive amount of heat, and it is all safe in there. Nobody was ever electrocuted in that building.
But it's been hit by lightning.
Constantly. It's got a lightning conductor on top of a building that actually changes polarity and physically draw the lightning to it to safely conduct it down to natural earth. So bonding is a crucial part of it.
Yeah, definitely.
And that's why I say it's completely misunderstood and neglected by most people. So that's one of the key important parts. Earthing and bonding works hand to hand. All your bonding gets connected to your earth for equipotential bonding. If people start applying equipotential bonding in their buildings and in the installations, their damages will so much more or less.
Will be way more. Well, will be like way less than obviously.
Way less. To give you a simple example, I always joke and said, me and my wife, we live in a shack. I'm a privileged guy who lives on a farm, and we've built ourselves a house out of shipping containers.
Yeah.
So there's basically no place where you are safe in a structure like that if it's not properly earthed and grounded. So I've built my house on the same principle as the Burj Khalifa. Made it a Faraday cage. My combined earthing is 0.086 ohms. In the last two rain seasons, lightning seasons, I had 9 direct hits on my house with down conductors, obviously.
Yeah.
One hit close to it on my electric fence, and my total damages was less than 4,000 rand of soft equipment.
Yeah.
But to give you an idea of how much soft equipment there is, I'm off grid on my on my solar system.
Yes.
So if anybody can make that calculations,
Yeah.
we're talking 7 figures
Yeah.
just for the solar system.
Yeah.
And my damages there were 0.
Yeah.
But I've applied the principle of a Faraday cage and equal potential bonding.
Yeah. I think we'll have to do another episode just of the Faraday cage.
Well, I can keep you busy for a day on it.
So, Braam, thanks for that. The second question, how do lightning and surge protection work in solar power systems?
Not only solar systems, it works
Okay.
in any instance, it works exactly the same. Lightning protection, your base from it is a simple risk assessment. Where do you start with a risk assessment? And I think this touches on one of the questions to follow. A simple risk assessment for a domestic house is quite easy. First, have a look at the cost of a house. Have a look on what is inside the house. Is it an upper class house? How many soft equipment is there? How many vulnerable equipment is there? What will be the total loss in monetary value, not in sentimental value, if that house could burn down? Now, that's things that you need to take in consideration. And that will give you a risk assessment. And then from that point, where you start by applying whatever the need is for them, and obviously what the owner can afford to protect it. If you've got a big building and there's a server room, etc., you're going to do utmost best to protect that server room. You don't want the whole system to go down.
Definitely.
If you look at banks, for instance, if their service is down, what about the internet banking? What about all their banking transactions for the day?
No.
It's chaos.
It affects everyone.
Absolutely. So it needs to be top-notch. And on those top-notch stuff, please don't use the electricians and a bucket brigade.
The Shady Shawns.
Yeah, the Shady Shawns. Yeah. Absolutely make use of the professionals. There is 2 big lightning protection associations in South Africa. The one is LPA and the other one is LPP, which I happen to be the chairperson for. And go and check out both on their websites, and you can make a decision which company or which association you want to work with. And get professional guys to do it. So most of us are in that game, are competent persons. We are trained, we know what we're doing, and 99% of those guys' feet are flat on the ground. If they don't know, they're going to contact somebody who knows, who's got experience to assist them. They're not going to pull a shady Sean trick. on you.
Exactly.
Because
so,
lighting and surge protection is expensive. But if you take in consideration what you're going to protect with it, that is the crucial part. If you go for surge protection and you buy the 300 Rand model and you're happy and your insurance is happy, it's fine. But for me, for instance, I'm off-grid. If my inverter gets hit, where am I going to get power from
Yeah.
while my inverter is in for repairs?
There's not a plan B.
The plan B is a generator.
Yeah.
That's the most expensive
Well, that's money.
way of getting power. And to have a generator running 24/7 is no joke.
No.
So I'd rather spend 500 Rand more and install a 800 Rand SPD and put one on the output, and I know I can maybe lose one of them, but my inverter is still running and I've got no inconvenience. I've
Exactly.
still got power. So we must not always think just money-wise. Penny-wise and pound foolish.
That there's Afrikaans saying goedkoop is duurkoop
Exactly.
in the
that.
long run, and I think also what we always say is you can't put a price on safety. That's the
Exactly.
biggest thing, especially when you're working with lives and people. Then you can't put a price on safety. So that's very insightful. And to add on that, why is proper earthing crucial for solar installations and electrical installations as well?
That is a very interesting thing enough. Unfortunately, most of the guys in the industry doesn't even know that. But it's typical, tongue in the cheek. Most electricians can't read or don't want to read.
RTFM, hey?
And well, it goes for the public as well.
Yeah.
People don't want to sit and look on a video for 15 or 20 minutes. They don't want to read a proper paper, but they want to read the short parts. The industry is governed by the OSH Act, the EIR, and the SUNS regulations. EIR is electrical installation regulations. In the SUNS code, it is very clear that for any additional or alternative power source shall have its own earth. You are not allowed to rely on the supplier's earth for various reasons. Simple reason. You live in a suburb, your house gets feeds from a street pole or a street kiosk. A guy who had a nice party on a Thursday or a Friday or a Saturday evening comes too fast around the corner, he takes out the mini sub or he takes out the kiosk. Where's your earth? It's gone. You've got a backup system
That
which
makes
is
sense.
relying on that earth. All of a sudden, your earth is floating. What do we mean by floating? It's not connected anywhere. Where is your fault current going to go? It wants to go back to its source. You touch something, you become the path. And your lights and water is going to be cut off immediately. So it's a huge risk. And there's certain readings that this needs to adhere to.
No.
When the whole OSH Act, the whole SUNS regulations, people think it's a lot of it's not. The guys who put that together, it's not a lot of monkeys.
Yeah, no.
It's done for a good reason. And the bottom line reason for any of these is basically for three things, is to protect people, property, and animals. If you protect that, that is in order, the rest is easy.
No. Yo, but that's a good example actually. If you think of it like that, it makes sense. Absolute sense.
Yeah, well, I had an instance about 2 years ago, and a guy phoned me up and he said, "Can you please help me? I'm doing tests here, and I just cannot get the values right."
No.
I said, "Well, you've got to have a look. Is there an alternative power source? Yes, no, the whole house is on solar, everything runs smoothly, but I don't get the correct readings. And he started talking to the people and make small talk with a domestic and a gardener. And then we find out that this client has got an outstanding bill from more than 100,000 rand with the council. So the council didn't come and switch off. They physically removed 3 meters of cable. So where's this guy's earth? It's floating.
There's no earth.
That's why he couldn't get readings.
Oh, my
Fortunately for them, nobody ever got shocked in that place. If somebody would have been shocked, they had an excellent chance of passing on.
Yo. Jeez, like, yeah, that's biggie rough. So can you walk us through a risk analysis for solar installation, giving that example just now, focusing on different types of protection and installation methods? If you can give us an example or two as well, I think it would be beneficial.
Risk analysis, I touched on it earlier. Basic risk analysis is, well, let me give you a sample. Maybe this can make it easier for people to understand. Mr. X is a wannabe property developer. But everybody starts at the beginning and starts small. Nobody jumps in at the deep end and swim 100 meters in a record time.
Yeah.
So he bought a property in an industrial area. Obviously, he had to make provision for parking, and it could fit in 4 shops. Industrial area, so what kind of business is he going to attract? The first guy who comes there is a guy who do fish and chips, because it's close to the coast, etc. This guy, what is this guy's risk if there is lightning? Maybe a point of sale? Laptop? What's his risk? It's a low risk. The next door shop, that area is a rural area. A lot of guys are still using bicycles. This guy opens up a shop to fix and sell bicycles. What is his risk? That guy works cash under the table. He doesn't even have a point of sale. So what's his risk? Zero.
Yeah, nothing.
Another guy comes and he rents a corner shop and he starts a sishinyama. What is his risk? Maybe a point of sale again. A fryer or 2 or something like that.
Maybe
but
that.
it's low risk. But the third shop is standing open for 6 months. He's got a potential guy who wants to move in there. But he actually don't want that guy in that area. But he's a small-time developer. He relies on the rent income to pay his bond. And after 6 months, he said to this guy, okay, you've got to come and move in now. I'll sign the contract for you. Guess who's moving in? An arms dealer. An arms dealer moved in there. Apart from arms, which is very expensive,
Yeah.
what does that got to do with my risk? Obviously, it's a high risk. He's got gunpowder. He's got ammunition in there. He's a super high risk client. Obviously, the neighboring guys need to have better fire protection. So this guy, if he's clever enough, is going to get that guy to pay for the other guys, and because of his risk, their risk goes now to a mini risk, to a medium size. It's not down at the bottom anymore.
No.
That's a simple risk analysis. It's done.
So you shouldn't always think of your risk, but maybe the shop next to you as well.
Absolutely. That's crucial. Now, if you go to bigger installations, for solar, for instance, you're going to megawatt installations. Don't try and do it on your own if you've got no experience. Be a specialist in the lightning and surge protection market. Get it. It is not that expensive. Get those guys involved. Let them do a risk analysis for you. You get it something properly and professionally done, and that's money you're going to save in future.
Yeah. Okay, so that's not a small thing. That's very important,
it's
if not the
crucial.
most important thing.
Yeah.
So could you share maybe a few tips for achieving earthing values below 10 ohms? I know you spoke about 0.06 ohms at your farm there. What's the perfect amount of ohms for earthing installation? I'm sure it probably differs, but if you can share some insight on that.
That is a big point of contention and points where a lot of guys get it wrong. Industry, let me start off there. Industry is also teaching the guys wrong. Because as a general comment, if I may,
Yeah.
most of the training centers nowadays are focusing on to get the guys to pass an exam. They don't teach them the tricks of the trade. As long as they pass the exam, they can put their money in the pocket and this guy's up and running. He's an electrician now, or he's a plumber, or whatever. All the trades, same thing. If he's got 50%, he passes. 51, I used to say that when I was studying as well, before I got more brains. If you've done 1%, you've studied too much.
Studied too much.
But for 49% of a subject, you knows
Nothing. Yeah.
So earthing, and it is written in the science, it's very clear there, for lightning protection, you need an earth array. And the same with solar systems. You need an earth array, not an earth spike. A lot of guys think, come down with a conductor, put one earth spike in the ground, and now I'm done. No, it's not. That's why industry teach the people wrong. It's got to be an earth array. It's got to be more than one till you achieve, for lightning protection, a resistance lower than 10 ohms. Now let's just elaborate a bit on lightning. A lightning strike is anything from 100 kA upwards. Now, to get to kA, to try and explain it for the layman, lightning can be anything from 100,000 up to millions of volts, and 50,000 amps and upwards. Now, you want to put one small little wire down with one earth rod and now you're covered? No, you're not. You're going to get fried.
Yeah.
So you need an earth array, and it shall be under 10 ohms for lightning protection. For earthing systems, your alternative power source shall be below 5 ohms, preferably 3.
Okay.
3 is the ideal, 3 and less.
Okay.
In this part of, if you talk earthing and bonding, the lower is better.
Yes.
Bigger is not better.
Bigger is not better in this
No,
case.
definitely not. The bigger you're going to spend big money, but you
Yeah,
need to get it as low as possible. So it's got to be under 5, preferably 3. And that's where most of the guys stop. But we're not done yet. On your mega installations, you normally have step down and step up transformers, which carries power over a long distance distribution systems. The moment you come to a transformer, excuse me, if you work with a transformer, you start becoming a grid. When you've got a grid, a substation shall be less than 1 ohm.
Ooh.
That's not that simple and easy. Again, don't try and do it on your own. You're just going to make mistakes and you're going to throw money in the ground and you're never going to see the benefits of it. Get a specialist in there to calculate it for you, to come and do soil resistivity tests, determine the best points and the way it's got to be earthed and the amount of earthing that needs to do, and then you're going to be successful.
Don't do it on your own,
No.
or don't do it on your own. On your own. So get a specialist in. That's the better thing to do. That's the right thing to do.
That's the right thing to do.
To do an analysis and tell you exactly what you need to do, how you need to do it.
On a domestic installation, it will be money down the drain. It's a waste of money to get a specialist.
Yeah, but
Not
these
always, but
megawatts,
most of the time.
yeah,
You can achieve it on your own, and it's going to cost you a fair amount of money.
yeah,
But to just ignore it, put one on a spike, it's just going to blow all your new soft equipment out of a wall.
and then it's going to be more expensive in the long run.
All electrical stuff works with smoke.
Yeah.
The smoke's going to come out, and to put it back is very expensive.
So thanks for that. So what are the recommended earthing values for different types of solar installations? I think you have obviously covered it now with 1 ohm for this mini substations.
Mini sub transformers.
Okay.
1 ohm.
1 ohm.
And lower alternative power source systems. In other words, you've even a domestic installation and you're only halfway there.
Yeah.
5 ohms.
5 ohms. Okay.
For lightning protection, 10 ohms.
10 ohms and less, obviously.
When on thousands and millions of volts and amps, 10 ohms is not going to make a huge difference.
And it's the same for electrical and solar installation. There's no difference.
It all falls under SSEG.
Okay.
I don't know if everybody understands the...
I think just explain it because I'm sure there's a lot of people. I only figured that out a few months ago. So I was also one of the layman's guys.
SSEG stands for Small Scale Embedded Generation. Anything that can generate power, if it's solar system, generator, diesel or fuel, any kind of fuel, wind generation, hydroelectric systems, all fall under SSEG. As long as it can produce power, it is a SSEG system. They've all got to adhere to the same rules.
All of them. So let's move now to the COC part. And I think this is going to get interesting. So how do you operate test equipment to ensure accurate results in solar installations? Now, before we started the podcast, we spoke about these values of meters, and I think you must just throw that into the mix as well when explaining.
Well, the first thing is read the manual. One crucial word was left out there on purpose.
Yeah.
But like I earlier said, people don't read. Especially electricians. They want to do something physically. He's probably going to ask his friend, how does this meter work? I've bought this new one. How does it work? That's easy. You just put it on that setting, push the button. Okay, sure. He doesn't know what he's doing.
Yeah.
You must read the manual. Find out what your instrument can do. How does it arrive at that answer? And there is so many examples of meters being used wrong. I see that on a daily basis. And it's well, actually scary. There's one reading that we use on COCs, on every COC, that I only found out a couple of years ago, but I've always done it wrong myself.
Yeah.
It's because we was never trained to do it, and apart from that, I never read the manual till I start getting results, and the results flagged it for me that something is wrong. And when I start studying the manual on the internet, because I didn't have it anymore, then I only found out what the reason is behind it.
Yeah.
So know your instrument. Once you know your instrument, then you can do proper testing.
Start with the basics.
Basics.
Start
always
with the
first.
basics. We always say, yeah, when the technical guys they get a lot of calls and then the simple answer is read the manual, and then and then I say, yeah, but it's easier to call you and just find out so that you can do the work for me. So a lot of our technical guys struggle with that. So what are the correct inspection, testing, and verification procedures according to SANS? So you can elaborate on the specific SANS code and stuff, but yeah, that's an area where I think a lot of people also don't read the manual and the regulations as well.
Well, apart from the manual and the regulations, regulations is a big thing, but they also don't read the test report properly. To give you an idea, is, and a lot of qualified guys don't know it, a COC means a certificate of compliance. The front page is the COC. The back page is the test report. And they married, and they cannot be divorced.
In community of property.
Not because of... They are paired and they go along. You cannot issue a COC without a test report. You cannot issue a test report without a COC. I see there's a trend in the market that a lot of installers say, yeah, but the owner has a COC, I just give him a test report that he can add to it. No, it doesn't work like that. SANS is very clear about it. Any electrical work shall have a COC. In the past, if you changed a plug which was broken or something like or faulty, we called it maintenance and you didn't issue a COC.
Yeah.
According to the EIR at this stage, any electrical work will be accompanied by a COC. So if you change a faulty plug, you will go through the correct test procedures and issue a supplementary for that, provided that there is an initial. That's a complete discussion on its own.
Okay.
We can
We could do that on another one.
yeah, we can speak about that one later on. So whatever you do, a COC shall be issued. And again, the guys don't read fully. There's a description on and a specific question, and you need to answer that, and you need, most of them, you need to do specific tests to answer that. And once you've got enough experience and start to understand these things, by just one glance at that measurements that you've done, you can see if it's compliant or there is faults. There's also electronic COCs available, like from the ECA and so forth, which makes the life so much easier. Unfortunately, the older guys, more experienced guys in the trade are very resistive to change, and they keep on writing with a pen and paper, and technology is here to stay, guys. Get the catch-up call. If I'm at my tender age, could learn that anybody else
Sure,
can.
the rest can as well. So on that question, I think the following questions, obviously speaking to that, what are the key requirements for creating a fully detailed test report for electrical installations specifically?
Well, firstly, you need proper instruments. And like my one colleague and friend always says, proper instruments is not a grudge purpose. If you've got proper instruments, you can get proper readings. If you've got proper readings, you can compile a COC to the best that there is on the market. You don't have to overspend. You don't have to go and spend 150,000 rand on an instrument if a 50,000 rand one can give exactly that. And there is so many manufacturers and good quality ones, and even ones that gives you a lifetime guarantee on the instruments. So go out in the market, do your research, and buy a proper instrument. Look after it, obviously. Don't throw it in the back of a bakkie. Worst place is behind your seat. But protect it. That's your investment. That is your diagnostic machine that will tell you how and where is the fault. But use proper equipment and do refresher courses. There is, for engineers, for instance, they need to do constant training. Doctors need it. On the engineering side, the guys always want SPD points because every 3 years he's got to renew his registration.
Yes.
Now, that's on the cards for the electricians as well, and I think it's a wonderful thing because everybody is going to be forced to do refreshing and to show that they've actively upskilled themselves to do proper inspections.
I think after this, we'll definitely get you in here to also do a few courses, because I think after this discussion, it's going to be necessary for most of the people watching as well.
No, absolutely. It will be good for me as well. I'm in the industry. I was supposed to be retired already, but I've got too much of a passion for the industry, and I like to help other guys to uplift their skills.
Exactly.
Unfortunately, in the trades, it seems like the electrician is a guy who normally comes last in the row, and there's too many shady shawns and lackatricians in the market, which unfortunately creates a bad vibe. A lot of these guys will just issue a COC, don't even come to site. A lot of in the solar market is guilty on that as well. A lot of people do the job, he gets an electrician to come in and do a COC. For both of them, it's illegal. And they both can land in court, and they both can get severely punished. You need a qualified wireman registered with the Department of Labour who is taking general control of that site from day one, not come in at day 20 and sign off a COC. That is illegal. That person takes responsibility for that site from day one. He needs to be regularly on site. He needs to act and do general control. It's the same. You've got to look at that as similar to a safety file. Are you going to send up guys working on a roof without proper training, working on heights, proper safety equipment, all your PPEs? That guy that didn't pitch for work this morning, are you going to get a guy from the street with a pair of flip-flops and send him up on a roof? No. Why not? It's common sense. He's going to get hurt. He's going to slide off a roof, and you're going to pay for him for the rest of your life.
No.
It's just stupidity.
No.
Now you want to bring an electrician afterwards. He doesn't have X-ray eyes. He cannot see that there's a joint made in a cable on a cable in a wireway. How must he see it? It's impossible. Now he gives a COC for it. Who's liable? Who's going to wear an orange jumpsuit? He. For a few bucks. It's ridiculous. Everybody also wants to undercut and get a COC as cheap as possible. Now, that I've stopped many, many moons ago. At one stage, I said, okay, I've got a new motto. I'm rather going to sit on my stoop hungry than tired and hungry. So, do one COC a day, do it properly and charge a proper price than do 10 to get the same kind of money, and you are liable for 10 installations instead of one, and 10 where you took a lot of chances and shortcuts.
Doing skimping work.
Absolutely.
Shortcuts.
That's a big problem. We're always going to have it with us, but we can try and minimize this. So we need to start acting, and we need to start proactively and do the job correctly.
So you mentioned the Department of Labour in the previous answer. So from the Department of Labour's perspective, firstly, how do they come into this, and what critical elements must be included in the test report that we spoke of for various installations?
Department of Labour is the step down from the OSH Act.
Okay.
They've got to enforce it.
Okay.
Now, how do you police a market as big as South Africa in electrical? You're going to need more inspectors than we've got policemen in South Africa.
Yes.
So it's basically impossible. So currently what happens, they only get involved whenever there is a complaint, injury, or death. That's where they get involved. If you buy a property, something is wrong or seems to be wrong on your side, you and your owner, how are you going to address that? Firstly, you get an AIA involved, Approved Inspection Authority. There is only one in the country at the moment. You get them involved, they do an inspection. Unfortunately, it's for your pocket. You can, however, claim it back from the electrician who wrote out that COC afterwards. They then will submit that to Department of Labour. And then Department of Labour gets involved. And then they will get you on the short and curlies and said, okay, here's your ultimatum, go and fix it, or if you don't want to listen, you can lose your license.
Will that be taken up to court then, and will there be,
Yes.
and then they can lose their license?
The AIA reports is a legal document, and that must stand up in court.
Sure. That's quite
Unfortunately, that costs money.
Yeah.
And from there, Department of Labour takes over. Now, they are not hunting people down. That's not their objective. They are also there to uplift the industry and to get everybody to a higher and better level. So what they do is they will give a guy a chance to fix up where he messed up. They can force him to go for training. Well, firstly, they're going to revoke his license and say, okay, you fix this. He's going to do maybe a test with an AIA to get his license back. And then he can continue. If it's bad case and the guy refuses, then it's for the court to decide what's going to happen with him. Unfortunately, these cases cannot be broadcast because of the POPI Act.
Mm-hmm.
So if cases that was handled, and myself was as a former AIA, if we can broadcast that, I think half of our shady shawns will immediately leave the market.
Mm-hmm.
But because of the POPI Act, we are not allowed to do that.
It's difficult because I think that will fix a lot of the bad vibes that are in the market.
Absolutely. Absolutely. It would have made a huge difference.
Because it's damaging the electricians or the electrical game as a whole.
Yes.
Solar installations as well, because that's affecting everyone. Because all of the end consumers or the end users are skeptical because of certain people they've worked with previously. And I
Yes.
think that's also where we come in with our trusted installer basis, where we need to adhere and make sure there are proper inspections and make sure everything is according to regulations with the Department of Labour, with the is it the ECIA IEC. What's it that you said?
Yeah, like you get the ECA,
ECA.
but ECA is an association.
Oh, it's an association.
Yeah,
Okay.
it's not compulsory to be
Yeah.
part of them. The same goes for green cards.
Ooh, that's another topic. That's another topic.
Yeah, this is I've got to be treading very carefully here.
Yes.
A lot of banks, most of the banks, insurance companies, have jumped onto the bandwagon and said, an installer or a solar company needs a green card. Green card actually means
Yes. Means nothing.
you have to be an IE, an installation electrician, or a MIE, a master installation electrician, to do a solar install. You as an owner of a company, of an installation company, don't need to be a IE or a MIE. As long as you employ one that takes over the general control on that site. But as soon as that person leaves your company, you've got to stop operating till you have replaced him and registered the new person with the Department of Labour. Now, a lot of instances and banks, etc., wants a green card. It's a further study into the market. It is not compulsory. It's compulsory to have an IE or a MIE on the site. The same goes for a single-phase tester. Single-phase tester are not allowed to sign off on a DC installation because he's not qualified to do that. And if he's not qualified and he signs it off, he is guilty of fraud. Now, the biggest problem in our market actually is the consumers. On the big installations, no issue. The issue comes in with domestic installations. The guy spends 250,000 Rand on a solar system or 100,000 Rand, but he don't want to spend 3,000 or 5,000 Rand for a proper electrician to do the job and to issue a legal COC. He wants to get the shady Sean for a 5 or a 700 Rand, and estate agents are very, very guilty as well. They want to push for the lowest possible price, and that's wrong.
Sure.
If we can educate those people to get that part out of a market, it will be a much better industry.
No.
Now, as a total summary of this, everything sounds negative. It's not true. Unfortunately, we as humans are looking into it to see the negative things. And the negative things will always stand out.
Yeah, they will.
So that's human nature. What I'm 49 years in the electrical industry. I can tell you there is much more positiveness, good guys, quality workmanship, quality installers in the market than shady shawls.
Yeah.
But for a client outside, go and do your homework. Do your homework.
Do your homework properly.
Yes, and as you said earlier in Afrikaans, goedkoop is duur koop. Get a proper guy with a good track record to do your install. Rather pay the 10 or 20,000 Rand extra in the beginning, and you know you're going to be hassle-free in the future. That shady guy, tomorrow is gone. Who is going to give you after-sales service? Now you're going to go back to the top guy, and he's going to nail you because you hurt him in the beginning. You told him to take a hike. Now he's going to take a hike into your wallet now.
In your wallet, which is actually fair.
Absolutely. I mean, somebody messed it up, and now he's got to come and fix it.
Now he's going to come fix it. So there's going to be more work. It's going to be more labor for that guy.
Yeah. Well, the trend in the market now is if you come to a shady installation If you rip everything out and start from scratch,
Yes.
it's much easier that way than to start and trying to fix things.
Yeah.
It's easier and faster. Rip everything out, install from the beginning, do it properly.
No. Well, I think let's end on a positive note where you said there's more good installations and Shady Shawns out there, and I think that's a good place to finish. So, Braam, thank you for your time. I think we'll definitely make sure we get you into one of our training events and make sure we do more of that. Because after this, I think it's going to be necessary, just as a refresher for most electricians and installers as well. So thank you for your time. We appreciate it. That's Busy Working signing out.